Good morning. My name's Kevin Hann. I'm the Technical Director of 33kV Limited. We're a NERS accredited independent connections provider working out of Haywards Heath in the middle of the southeast of England. We normally do design, construction, commissioning and fault repairs on high voltage networks, either for adoption by the DNOs, mainly UK Power Networks, Western Power and SSE, but we also do a lot of industrial engineering works for data centres and factories. We are currently providing services for gas generation schemes and solar schemes, and we have an office in Scotland which is based on the renewable industry and in particular the wind energy sector. Over recent weeks we have been heavily involved in the ENA's loss of mains protection systems, whereby we are instructed by our clients, which are the owners of the solar farms and wind farms, and in some cases biogas and gas, to go to site and change the relays so that they are now G59 compliant as far as the vector shift and the rock-off elements are concerned. What this means in practice is that we get given what the client believes is the protection relay on site, and we then go out, and there's three things that we can do. We can either change the relay, which is the worst case, for a new version. We can upgrade the firmware in the relay, or we can just change the settings on the relay. The settings are moved from vector shift to rate of change of frequency, and the next session will explain why we do this. I'd now like to address the reasons behind the accelerated loss of main scheme. This was introduced after a number of incidents on the grid, the last one being in August 2019, when large amounts of generation were lost with a resulting blackout of some areas. One of the reasons this happened is because of the amount of distributed generation. Typically distributed generation, solar, wind, and to a large extent now gas generation, biomass, all has loss of mains protection. This loss of mains protection was always seen as a need to keep the generation off of the system so that it wouldn't come back out of sync with the rest of the system and cause danger and cause possibly low voltage. Because there's now so much distributed generation, it is seen as being an essential part of the UK power mix. So the desire now, and particularly with G59, is to keep that generation going and not trip off generation circuits if there is any blip on the system. Now, why does vector shift cause so many problems? The reason is it's an instantaneous protection. If the frequency suddenly changes, then the protection will come off. Now, we know through testing that this actually means that a circuit breaker that is controlled by a G59 relay with vector shift will probably trip in about 60 milliseconds. So any transient situation that is going on the network will cause that generation to come off. Now, there's three issues that we know with this. The relay needs to sample the voltage sine wave, and if there's any distortion on that due to some local or remote issue, then the sine wave is distorted and the relay will see that as a rapid change in frequency and will trip. Another incidence of false tripping is that when you get large power flows over a circuit, The only way that that can happen is if the voltage angle is changed. So a system could be sitting at, say, 1 degree different to the main generation, and if there's a fault, that can suddenly move to 6 degrees. That is seen as a sudden change in frequency and will then cause the protection to trip. There's another extremely dangerous incident that we've encountered on a number of occasions, in that because vector shift is so quick to operate, any fault inside a solar farm, such as a flashover on a 11 or 33 kV bushing, will be detected because there's a high fault current flow. However, the relay is normally delayed, typically 200, 400 milliseconds for an overcurrent or earth fault protection to operate. However, because the vector shift sees a distortion in the sine wave, it will trip immediately and beat the protection. We've seen on a number of occasions when we've looked at relays that we get a relay start and a relay finish, because the fault has been cleared by the circuit breaker opening under vector shift rather than the overcurrent or earth fault. The danger with that is that it's seen as a normal G59 type event, and then it recloses. And we've had a number of instances where circuit breakers have been damaged because of repetitive auto reclose. The way that the accelerated loss of main scheme works is that our client would submit a list of sites that they wish to get funding for. That is then sent to the relevant DNOs, who put it on a database and either accept or reject the claims. The instructions from the ENA are that the DNO will witness those sites that they deem necessary to be witnessed. And very often they will come out and they will watch our engineers do the changes and sign the form off. However, this isn't always the case, and this seems to be the decision of the DNOs that actually do this. We don't have to organise it because it is the requirement that the DNOs make that decision. In the current climate, of course, the last thing we want to do is have a lot of people on site. So up until last week, we were still going to site, working single-manned because we all have safety precautions and RAMs that cover that. And we've been going on to site sometimes with just one representative from the operations and maintenance provider, but very often we will arrive on site, we will call in and we will get a transfer of control whereby we are allowed to do all of the work on site ourselves. So there's extremely little risk. Our staff will be travelling alone, arrive on a site alone, work alone, and then travel back. So there are no COVID-19 risks as we see it at the moment. UK Power Networks have an odd system. They have said that they will require each of our engineers to have been witnessed previously within the UKPN area on each of the relays that we carry out tests or changes to 3 times. That would mean that one of our engineers would have typically have to have been witnessed 3 times on a MICOM relay, 3 times on a COMAP Mains Pro, and 3 times on a COMAP IntelliPro, because they're the relays that we're seeing most of the time. We're also seeing a number of other relays. There's an ABB Ref 615 which has cropped up a number of times, and out of the 130 relays that we've now done, we've come across 2 of these. So to have been witnessed 3 times on this particular relay is practically impossible, and it would need UKPN to come out and witness us. Not only that, they are saying that if the relay is connected to the 33 kV side, it will need a set of witness tests for that, but it will also need a set of witness tests if it's connected to the low voltage side. And this is quite ridiculous, as in many cases the connection is the same, there's probably still the same sort of VTs. Added to that, UK power networks are still randomly attending sites. And after all, the DNO knows when all these instances are being carried out, so they should be able to arrange the site visits. So the essence of this part of my presentation is that the DNOs aren't necessary. The witness testing that we're being asked to perform now, with a DNO engineer actually watching us and also submitting far more forms than we ever did when we commissioned the relays in the first place, seems to be a ridiculous situation. As a professional organisation, we feel somewhat hurt that we have to be witnessed, and by providing all of the photographic evidence, the test files, and the fully signed off and completed G59 certificate, we believe that we should be allowed to carry on. There is now so much distributed generation that this generation is essential. Having a look yesterday, the renewable sector was round about 50% of the generation mix. Admittedly, a large part of that will be offshore wind, which isn't exactly controlled the same. So if you forget some of that, if there is a G59 vector shift event, it is likely that up to 50% of the generation in the country could fail. That is worst case, but even losing 20% would have a significant effect on the UK's capability to provide power to hospitals, food distribution centres, data centres who are providing all the Zoom chats and all of the social interaction these days. We therefore think that it is extremely important that the accelerated loss of main scheme is not halted but is actually ramped up. Because of the downturn in the demand in the UK, renewable energy is actually providing a greater percentage of the generation. This is because generally small, that's 5, 10, 30 megawatt solar sites and typically 30, 40 megawatt onshore wind farms aren't constrained. There are some constraining issues, but these are generally associated with issues on a particular network. So that means that these sites are producing power all day long. If there is an incident, then that generation could be lost. Now, under normal times, there is far more rotating plant, and we all know that inertia forms a great part of this. More rotating plant gives the system durability. So under normal conditions, the amount of generation provided by the rotating plant is a higher proportion than that from inverter fed systems that has no inertia. So this means that if there is a G59 event, similar to what happened in August last year, it is likely that the renewable generation will be lost. And as it's a larger percentage, the impact on the grid will be far higher. So in summary, what we're asking is that the ENA and the DNOs actually review their decision to stop doing this work. We believe it's essential for the ongoing support of the grid system that this accelerated loss of main scheme continues. We also believe that certain organisations, typically, and I would say this, that typically ICPs with a NERS accreditation, and by the way, we also have ISO 9001, so we are not going to skimp on anything. I believe that organisations such as ours should be allowed to continue this essential work.